All right, so we plugged in those x values and gotten the y values to go with them. The next thing to do is just draw your graph. This graph, needs to go. We look at our y values to know how tall it should be. It's got to go at least up to 9 and down to -11, so it's pretty tall. And then our x values, it doesn't have to be real wide because our x values are not huge. We picked them that way. So, bless you again. So that's pretty tall either way. Plot those points: -2, 9, 2, 4, 6, 9, -1, 4, 0, -1, 1, -6, 2, 3, 4, 5, 6, and 2, -11, 7, 8, 9, 10, 11. Pretty steep line there. Again, draw your straight line, put the arrows on the ends. Get those 5 ordered pairs. The red line, remember, represents every ordered pair that goes with that equation. Okay, that's what that line represents. When we get a little further, we'll be dealing with lines that are crooked. We'll, in Algebra 2 and college algebra right now, we've been dealing with lines that do this. Well, that line still just represents a bunch of ordered pairs. That's all it really is. Okay, ours is straight right now. We'll put some curves in it later on in the class, but right now it's straight. All right. So here we had one, didn't have any fractions in it. So let's get to one that's got some fractions in it and see how that changes what x values we pick. Okay. Example C, we got y equals 1/2 x minus 4. Is y by itself? Yeah, so we're ready to make our table. We want to make sure y is by itself before we make our table. And now here we got to pick our x values out of this. Now, that fraction in front of x, we want to make things easy on ourselves. So if it's a half, what kind of numbers are easy to take half of? 2, 4, 6. Yeah, 2, 4, 6, those are all what kind of numbers? Even numbers, okay? So we look at that denominator, and it's a 2. Whatever that denominator is, you want to look for numbers that are divisible by that. So if it was a 3 on the bottom, you'd look for numbers like 9, 6, and 3 that are divisible by that. So I want to go a couple of negative ones. I can still use 0, and then a couple of positive ones. So I'm going to use -4, -2, 0, 2, and 4. That's going to make the math easier on us. Would it mess it up if I did -2, -1, 0, 1? No, it's still going to get you the same picture if you do it correctly. It's just going to be harder to do the math because you got a fraction to deal with when you do an odd number. Okay? So when I plug in -4, what's half of -4? -2 minus 4 would be -6. Then plug in the -2. That'd be -1 minus 4, -5, right? Plug in a 0. 0 minus 4, -4. Plug in a positive 2. 2 times 1/2 is 1. 1 minus 4, -3. I bet the next one's -2. Seems like a pattern there. 4 times 1/2 is 2. 2 minus 4 is -2. So we get those y values out of that. So all negative y values. So when I draw my coordinate plane, I don't have to have much room in the positive direction of the y-axis at all. So I don't put much room there. Okay. Your coordinate plane doesn't have to be symmetric all the time. And if I can get over that with my OCD tendencies, you can too. Because I like for it to be symmetric, but it doesn't have to be. All right. Let's plot those points. -4, -6, -2, -5, 0, -4, 2, -3, and 4, -2. Nice straight line with our dots. should make that, everything we do today should make a straight line. Draw a line connecting those with arrows on its end. Not too bad. Pretty easy thing to do. All right. Leave that there. You can still see it. Example D. Let's go to this one. Y equals 2. And that's it. Man. That's weird. Y is by itself, so I can go ahead and take my table. There's not a fraction in it, so I'm just going to go -2, -1, 0, 1, 2. What's the y value when x is -2? There's not an x in there to plug into. What's the equation say? It says that y equals 2. Always. So what would the y value be for this -2? It'd be 2. What would the y value be for -1? 2, because it says y is 2 always. So they're all the same. Y value anyway. So when we look at that as a graph, if I look at those points, what kind of line are we seeing here? Straight is not the right answer. It is straight, but it's horizontal. Anytime it's y equals a number, it's going to be a horizontal line at that number. So that you could skip this making the table jazz that we did here. That if it's y equals 2, there's going to be a line at y equals 2 straight across. If it was a y equals -5, you'd go down here to -5 and you put a line straight across. Anytime it's y equals a number, it's going to be a horizontal line. There can't be an x in the problem and it'd be that. But as long as it's y and just a plain number, it's a horizontal line at that number on the y-axis. Always. Okay? Yeah, there is one. That's good. You're reading my mind because that's the next example. What if it's x equals 4? Something like that. If I think about the table for that, what's it telling me x has to be here? 4. So when x is 4, at whatever y value, what about -2? Well, at -1 is a y value, x is still 4 because it says x equals 4 always, every time, x equals 4, no matter what. So when I look at the y values, I'm putting those, that should be a positive one. X is always going to be 4. And if I plot those points on this coordinate plane, four -2, right there, 4 -1, 4 0, 4 1, 4 2. That's how we build a vertical line. And the idea here is that you see x equals a number is going to be a vertical line. Anytime it's x equals a number, we're going to have a vertical line at whatever number that is. So here we have x equals 4. So it's a vertical line at 4 on the x-axis. If it were x equals -8, we'd go over here to -8 and we'd put a vertical line. That we could skip this table mess for those special ones. Okay? When it's got y and x both in it, I want you to find the table on it in 4-2. And we're about to do something with 4-3 in just a second as well. All right. Now, let's look at some more kind of special ones that they kind of throw into this section that will help you as you progress through some math classes. Example F. Let's say it's y equals 4x minus 6 for a domain X is greater than or equal to 1. What's domain? What letter does that go with? No. X values. What does it tell us about the domain? So what's the smallest X value that I can pick? 1. And then I have to pick 2 or 0. Why 2 and not 0? 0 doesn't fit the inequality. 0 is not greater than or equal to 1. So I've got to go 1, 2, 3, 4, 5 and plug those in. Because the domain told me it had to be X values greater than or equal to 1. Okay. So this is it's called a restriction on the domain, is what that's called. But it just means you're limiting your X values to a certain kind. The kind we're having on this one is things that are 1 or higher. We picked the easiest ones we could that are 1 or higher. Plug those in. 4 minus 6 would be negative 2. 8 minus 6 would be positive 2. 12 minus 6, 6. 16 minus 6, 10. 20 minus 6, 14. All right. And then we can graph that. So I'm going to have plenty of room in the positive direction and a little bit of room in the negative direction with the y. Plot those points. 1, negative 2, 2, 2, 3, 6, 3, 4, 5, 6, and then 4, 10, 7, 8, 9, 10, and then 5, 14, 11, 12, 13, 14. Nice straight line. Now here's the difference in this one and how we draw that line. That line starts at 1 and then goes to the right with the X value. So it's not got arrows on both ends. It's only got arrows on one end. That direction, because there's no X values that are less than this 1 here. Okay, so we just start there and go because of the restriction on that domain. Okay, restrictions on a domain tell you, okay, this is only a certain part of that graph. All right. Let's do one more that's at a restricted domain before we go to lunch. Let's say it's y equals negative 2x plus 5 for domain negative 2 is less than or equal to x is less than or equal to 4. This one's a little bit more restrictive. What's the smallest x value that I can pick? Negative 2. What's the largest one I can pick? Positive 4. I should have picked some in between there. What are some numbers that are between negative 2 and positive 4? Negative 1 and 0. 1 is in there. That gets us 5 of them. That's enough to get the good picture of the line. And then we take those and plug them in. Okay, so negative 2 times negative 2 is 4 plus 5 is 9. 2 plus 5 is 7. 0 plus 5 is 5. Negative 2 plus 5 is 3. Negative 8 plus 5, negative 3. All right. And then we go and we plot those points on this line, on the Cartesian plane or coordinate plane. I used the wrong word there. So negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just enough space. Negative 1, 7. 0, 5. 1, 3. And then 4, negative 3. Now, will this one have arrows on either end? Why not? It's restricted on both directions, right? It only goes between the x value of a -2 and the x value of a 4. So this one does not have arrows on the ends because it's restricted by that domain. That's not going to happen on a lot of them, but it does happen. And I do want to show it to you. Really, there's some things that we do in Algebra 2 that this is directly related to. Like the first week of Algebra 2, this directly relates to it. But it's restricted from -2 to +4, so that no arrows on either end of that one. Okay. All right, that gets us to the end of 4.2. We're going to actually do 4.3 today as well. So we'll pick that up and just a few examples of that right after we get back from lunch. Okay. So example H, we're going to change what we're doing here, and we're going to try to find the X and Y-intercepts of the equation, okay? The X and Y-intercepts. What that means is we're going to try to find where this equation is crossing the X-axis, that's the X-intercept, and where it's crossing the Y-axis, that's the Y-intercept. So that's what we're going to find here for this particular problem, okay? And when you want to find the X-intercept, when we think about the coordinate plane, we're going to graph it as well. So I'm just going to go ahead and draw my coordinate plane. And let's think about what's an ordered pair that's on the y-axis look like. All right, for example, what's this ordered pair right here? 0, 3. What's the 0 part? X. That's on the what? The y-axis, okay? That's where it's located. So if I'm going to find the y-intercept, I'm going to put a 0 in the place of what in the equation? What's the 0 in the place of here? The x. So that's what I'm going to do to find the y-intercept is plug a 0 in for x. The y-intercept, we do 5 times 0 minus 3y equals 15. So we now have -3y equals 15. How do we solve that for y? Divide by -3. Y is equal to, yeah, that's right. -5 is right. So our y-intercept is at this point 0, -5. So I would go to 0, -5, and I'd put a dot. Where that point is at. Okay. To find the x-intercept, where would we put a 0? In for y, because any point that's on the x-axis, like this point right here, is 1, 0. The 0 is in the place of the y. Okay. So I have 5x minus 3 times 0 equals 15. Well, that gets me 5x equals 15. Divided by 5, x is equal to 3. So the x-intercept is this point 3, 0. So I go to 3, 0, put a dot. You plug a 0 in for x to find the y-intercept, and you plug a 0 into y to find the x-intercept. It's two separate problems that you're doing. Yeah, if there's x and a y there, yeah. To find whichever intercept you're trying to find, you plug a 0 in for the other letter. And there we get the line based on those 2 points, 2 very important points, instead of having to, doing the 5 ordered pairs there. So this is actually coming out of section 4.3 that we're doing that, okay? Let's look at another one. Let's say we want to find the x-intercept and y-intercept. and graph. Okay, so we would, we've got this equation, x plus 2y equals 8. Let's find the x-intercept first on this one. So if I'm going to find the x-intercept, where do I put the 0? And for y, the x plus 2 times 0 equals 8. That's x equals 8. No more work to do. X is by itself. Then we've got x. So the ordered pair is 8, 0. Let's find the y-intercept. Where do I put the 0 if I'm trying to find a y-intercept? In the place of x. 0 plus 2y equals 8. Well, that's just 2y equals 8. Now what? Divide by 2. Y is equal to 4. So the ordered pair would be 0, 4. Now when I go to graph that, all I've got to do is plot those two lines and connect them. I need to go to 8, 0. Then I need to go to 0, 4. I'm going to get a line connecting those two. X and Y-intercepts. Not too bad. Still just plugging in 0 and solving an equation. So solving equations like we did in chapter 3, still part of this game. Will be the rest of the year. All right. Let's look at another one that maybe doesn't work out as cleanly as this one might the last two have. Let's say we had 4x minus 2y equals 10. I want us to find the x and y intercepts. And then we'll graph it. Okay. So to find the x-intercepts, what do? Plug 0 in for y. 4x minus 2 times 0 is 10. 4x equals 10. Divide by 4. 5 over 2. We get a fraction. That's okay. That's still the x-intercept. How do I find a y-intercept? Put a 0 in for x. So 4 times 0. 2y equals 10. So that'd be negative 2y equals 10. What do you do to solve that? Divide by negative 2. Y is negative 5. So 0, negative 5 is that ordered pair for the y-intercept. A lot of times we have trouble when that's a fraction as an ordered pair. We'll go to negative 5 on the y-axis. That's where that's at. That's the y-intercept. The x-intercept was at 5 over 2, 0. Where is that at? 2, how many times does 2 go into 5? 2 times with how many left over? A half. So it's like 2.5. So I go to 2 and then go halfway to 3. And that's my x-intercept. So we're going to have to estimate a little bit. Sometimes, think about it as either a decimal or a mixed number, but we're going to report it as an improper fraction. Answer I want you to write down is an improper fraction, but when you go to graph it, you want to think, oh, what is that as a decimal so I can estimate where it's at, 2.5. There's our line connecting those two. Okay. Whatever intercept you're trying to find, that's the letter that's left. Trying to find the x-intercept, the x is left in the problem. Trying to find the y-intercept, the y is left in the problem. That's you're going to see that happening. Okay. All right. I told you it was short after we got back from lunch, and it is. So let's look at our assignment for the rest of the day. The first page, page 219, we're doing numbers 11 through 21 odd, and then 27, 29, and 31. On 11 through 29 odd, I want the 5 ordered pairs. And the graph on those. That's what we did all that before lunch with on those. And then 27, 29, 31 is a little like so a few word problems with that stuff. Okay. So that's not that many problems, not that many graphs to draw. On 229, which is what we did after lunch, that's the X-intercept and Y-intercept stuff. Let's do numbers 5 through 15 and just the odd ones on that. And on this one, I don't, on those 5 through 15 odd, don't draw the graph. Find the intercepts only. Don't draw the graph on those. On 17 through 27 odd, intercepts and graph. So we're looking at 5 graphs from the first section. Yeah, that's 10 problems with doing the odd ones. It's half of that. And then 5, and then here we're looking at 5 problems just finding the intercepts, and then 5 graphs with the intercepts in the graph together. So we're looking at, less than 20 problems. You've got until time to leave to do that. That what my plan is that you get done. You don't have to take it home. If you don't get done, then you do need to take it home and finish it. But that's what you need to work on today for that. All right.